Alright, for number 1, when you rewrite this, x is the base, whatever is here is the base of your problem. This is the root, and remember the root goes underneath the ground, so underneath the fraction, and that's the exponent that goes on top. For this one, you're going to change it backwards, so the bottom number is the root, so this is the square root of 25, and that number is the exponent to the third power. Well, the square root of 25 is just 5, and 5 to the third power is 125. For number 3, again, this is going to be the cube root of 64 squared. And the cube root of 64 is what number times itself 3 times 64. If you can't come up with that, you could just do the factor tree. 16 and 2, 4 and 4, 2, 2, 2, 2. So there's a group of 2's here. You need a group of 3 because this is a cube root. If it was a square root, you would just need groups of 2. So there's 1, 2 groups. So in parentheses, there's going to be 2 times 2, which is 4, and 4 to the second power is 16. For this, if the exponent's negative, move it. So this is x to the 5th. X is positive, so that stays. Y to the negative 7 moves down and becomes positive. X to the negative 3, y to the negative 3 moves up. And you subtract. X to the 5th, x, since the bigger exponent is on top, x will be in the numerator. And 5 minus 1 is 4. Since the bigger exponent is in the denominator, y is going to end up in the denominator, and 7 minus 3 is 4 as well. So that's your final answer for number 4. For number 5, take care of the exponents first. So this needs to distribute to the exponents. So this is 5a to the 11, b to the 3rd, negative 2 squared a to the 10th times negative 3 times a times b. Well, negative 2 squared is 4, so 5 times 4 times negative 3 is negative 60. A to the 11th times a to the 10th times a to the 1. You add the exponents, 11, 10, and 1 makes 22. B to the 3rd, b to the 1st makes b to the 4th. Six, all of this stuff is to the 0 power, which means it's 1. And all of this stuff times 1 is just itself. So it's negative 7 p q r to the 4th. Number 7, again, distribute the exponents. So this is a to the 12th, b to the 18th. Number 8, make sure you put an exponent on the 4 so you don't mess up. Distribute the exponents. So this is negative 4 to the 3rd power, x to the 15th, y to the 6th. And negative 4 times itself 3 times is negative 64, x to the 15th, y to the 6th. Final answer. Number 9, start off by distributing the negative exponent. So this is 4 to the negative 3, p to the negative 12 over q to the negative 21. And since the exponents are all negative, they are all going to move. So this is going to be q to the 21 on top over 4 to the 3rd, p to the 12th on bottom. But you can evaluate 4 to the 3rd power. So this is q to the 21 over 4 to the 3rd power is 64, p to the 12th power remains. And that should be 21. 10. We are going to distribute the exponent. So this is 5a to the 8th, b to the 3rd, b to the 4th, times negative 6 squared times a to the negative 12th. Well, negative 6 squared is 36, and 36 times 5 is 180. a to the 8th, a to the negative 12. 8 minus 12 is a to the negative 4. And b to the 3rd, b to the 4th gives you b to the 7th. So overall, this is 180b to the 7th in the numerator. But since this exponent is negative, it needs to drop like it is hot to the bottom. For number 11, 21 and 3 can divide. That leaves you with a 7. And let's just move all the negatives first. A to the 5th, b to the 2nd, a to the 2nd moves up, c to the 9th moves up, b to the 7th stays down, c to the negative 2 moves down. Okay. Oops. So this is equal to 7 on top of the fraction. We have a to the 5th, a to the 2nd. They combine to make a to the 7th. We have b squared, b to the 7th. That means b will end up in the denominator because it's bigger in the denominator. And 7 minus 2 is 5. And then 9 minus 2 is 7, so that's c to the 7th. For number 12, we're going to distribute only twice. So this is m to the negative 5th, n to the 3rd, m to the 8th, and to the negative 4th. So negative 5 plus 8, that gives you m to the 3rd. 3 minus 4 gives you n to the negative 1. And you drop the negative exponent to have that as your final answer. That's the first page. Next page, when you have complex roots like this, put parentheses around everything underneath the root. So this is x to the 3/5 in parentheses, and the 6th root turns into the 1/6 power. Since they're separated by parentheses, you multiply. 3 times 1 is 3, 5 times 6 is 30, and 3 over 30 reduces to 1/10, which means your answer is B. Next problem. Okay, we need to get these guys in similar form so we can combine them. So let's do that. Sorry, my finger was scaring me. I don't think it's healing right. Anyways, so this is 7 to the 3/10, and this one turns into 7 to the 3/5 because the root goes on the bottom. And to add them, we need common denominators, so we're going to multiply this top and bottom by 2. So 7 to the 3/10 times 7 to the 6/10, that combines to be 7 to the 9/10, which is A. 15. Distribute that to the exponent, so this is 2 to the 6th power, x to the 3rd power. And 2 to the 6th power becomes 64, which is an answer of C. 16. So 7 to the 2/3 over 7 to the 3/6. We're going to multiply this top and bottom by 2, so this becomes 7 to the 4/6 over 7 to the 3/6. And since you're dividing, you are going to subtract. 4/6 minus 3/6 gives you 7 to the 1/6. The answer is D. 17. We need to add the exponents, so I'm going to multiply this top and bottom by 5, this one top and bottom by 3. So 11 to the 5/15 times 11 to the 9/15 is equal to 11 to the 14/15. And since it said to leave in radical form, we're going to change this to the 15th root of 11 to the 14th power. For B, same thing, multiply top and bottom by 5 to get common denominators, top and bottom by 4. So 5 to the 5/20 times 5 to the 8/20 becomes 5 to the 13/20 because you add the exponents. And since you want it as a radical, this is the 20th root of 5 to the 13th power. Number 18. This will be 18 to the 3/4 power times 18 to the 6/4 power, which means this is 18 to the 9/4 power. Since I'm only looking for the numerator, x is equal to 9. For number 19, again, put that in parentheses. So 6 to the 1/2 to the 1/7 power, and multiply the exponents to get 6 to the 1/14. I'm just looking for the bottom number, so x equals 14. 20, this is 12 to the 3/5 power times 12 to the 8/5 power, which becomes 12 to the 11/5 power. I'm only looking for the numerator, so x equals 11. For 21, this is 4 to the 9/4 times 4 to the 1/4, which becomes 4 to the 10/4 power. So if you put parentheses around the base, you could rewrite that as 2 to the 2nd power inside parentheses to the 10/4. And we can multiply this. 2 times 10 is 20, 1 times 4 is 4, and 20 divided by 4 is 5. So this is 2 to the 5th power, so x equals 5. For 22, simplify. So since we're adding, we can just drop the parentheses. 4 plus 3 is 7. 11 root 5 minus 1 root 5 is equal to positive 10 root 5. Remember, in front of the root, there's always a 1 that you can't see. For number 23, distribute the negative. So this is 8 plus 10 root 13 minus 5 plus 4 root 13. 8 minus 5 is 3. 10 root 13 plus 4 root 13 is 14 root 13. (24) 5 root 13 minus 7 root 13 is negative 2 root 13s. You just combine the coefficients. That's irrational. Those can't combine at all, so you just leave them as is. Irrational. 3 plus 4 is 7. 6 root 17 plus 2 root 17 is 8 root 17. That is irrational. The square root of 9 is equal to 3. So 3 times 14 is 42. That's a rational number because there's no radical left over. 5 times 2 is 10. Root 3 times root 3 is root 9. And the square root of 9 is 3. And 10 times 3 is 30, which is rational. Negative 2 times 7 is negative 14. 5 times 3 is 15 under the root. Can't simplify that, it's irrational. Okay, so we want to basically simplify all these problems and make sure it looks like that. So start off with this one. This is the cube root of 27 squared times x to the 7/4. So the x is already taken care of. That base is fine. We just got to make sure this becomes 9. So the cube root of 27 is 3, and 3 squared equals 9. So therefore this is all 9 times x to the 7/4 power, which is equivalent. Let's try b. So this is 9 times x. This number is the root. 4, that number is the exponent. 7, that is equivalent. In this problem, 27 does not have any exponent at all, and it is not equal to 9. So therefore that is no. This one is going to be 9x times x to the 3/4 power. and that's x to the 1 power right there. So we need to add some fractions. 1 over 1 plus 3 over 4. That becomes 4 over 4 plus 3 over 4, which is 7 over 4. So this is 9 times x to the 7/4 power, which is equivalent. Okay. In this problem, again, I very heavily emphasize parentheses when we're talking about roots. So this is 9x to the 7th in parentheses to the 1/4 power. Distribute that 1/4, so this is 9 to the 1/4 x to the 7/4, but 9 shouldn't have an exponent on it, so therefore this is not equivalent. For 26, 3 equivalent expressions. You can pick a million of these. There are infinite solutions to this. You just got to make sure they multiply to negative 20. So a to the 4th to the negative 5, a to the 2nd to the negative 10, or you could just switch them as a to the negative 2 to the positive 10. Those all work. Same thing with this one. This could be a to the 2nd to the 12th power, or it could be a to the 12th to the 2nd power, or it could be a to the negative 12 to the negative 2 power. You just got to make sure they multiply to reach the original exponent. Okay. And 28 is the same type of problem as 25. So when you rewrite this, this is 8 times x to the 6/3 power, which is not 5/3, that's no. This is the 5th root of 32 to the 3rd power, x to the 5/3. The 5th root of 32 is 2 to the 3rd power times x to the 5/3, and 2 to the 3rd power is 8, so it's equivalent. Okay. Again, everything in parentheses. 8x to the 5th power to the 1/3 power. Distribute. So this is 8 to the 1/3 x to the 5/3. But 8 shouldn't have an exponent, so it's not equivalent. This becomes the square root of 64 times x to the 5/3. And the square root of 64 is 8. So 8x to the 5/3, it is equivalent. And this one is 8x to the 1st times x to the 2/3. So this becomes 8x to the 3/3 times x to the 2/3, which combines to be 8x to the 5/3. Remember, all I did was change this one into a 3 over 3, so that way I could combine my exponents. And that is equivalent. Okay. So there are the answers to your study guide. I'm sorry I went through it so quickly, but I was running out of time before the next period starts. Good luck. If you have questions, please email me. Have a wonderful evening.